The history of science, discoveries, and developments. Humankind has always been inquisitive, needing to understand why things behave in a certain way and trying to link observation with prediction. For example, since prehistoric times, we have observed the heavens and tried to make sense of the seasonal changes in the position of the sun, moon, and stars. The history of science encompasses all three major branches of science: natural, social, and formal, can be traced to ancient Egypt and Mesopotamia. In prehistoric times, knowledge and technique were passed from generation to generation in an oral tradition. The earliest Greek philosophers, known as pre-Socratics, provided competing answers to the question found in the myths of their neighbors: how did the order cosmos in which we live come to be? Plato and Aristotle produced the first systematic discussions of natural philosophy, which did much to shape later investigations of nature. In the Middle Ages, the classical learning continued in three major linguistic cultures and civilizations: Greek, the Byzantine Empire, Arabic, the Islamic world, and Latin, Western Europe. The 19th century saw the birth of science as a profession. William Wilhelm had coined the term sciences in 1833. Karl Marx developed an alternative economic theory called Marxian economics. Modern sociology emerged in the early 19th century as the academic response to the modernization of the world. Among many early sociologists, Emil Durkheim, the aim of sociology was in structuralism. Max Weber was concerned with the modernization of society through the concept of rationalization. The beginning of the 20th century brought the start of a revolution in physics. The long-held theories of Newton were shown not to be correct in all circumstances. Beginning in 1900s, Max Planck, Albert Einstein, Niels Bohr, and others developed quantum theories to explain various anomalous experimental results by introducing discrete energy levels. Big Bang, George Gamow, Ralph Alpher, and Robert Herman had calculated that there should be evidence for a Big Bang in the background temperature of the universe. In the early 20th century, the study of heredity became a major investigation after the rediscovery in 1900s of the laws and inheritance developed by Mendel.
This relates to some intellectuals and their discoveries, specifically scientists. Scientists are driven by their curiosity, critical thinking, and creativity to explore the nature and physical world, and that leads into discoveries. One of the scientists that I'm referring to is Nicholas Copernicus. He was born on February 19, 1973. He graduated at Kharkiv at 21 years old. This is the photo of Nicholas. On his studies, he did not do anything extensive. He didn't need any people to test his ideas. His ideas are one of the examples of thought experiment. He was famous through his studies called heliocentric system. This is also the visual presentation of heliocentric system. It explains itself that the universe itself revolves around the sun rather than the earth. At this point, it is widely believed that the universe revolves around the earth. The problem with this theory was that in order for the geocentric model to be possible, the sun would have to orbit around the earth in a crazy spiral movement. What I mean by the spiral movement is that if this is the earth and this is the sun will spin or orbit or revolves around the earth in a crazy spiral movement. What I mean is that when the sun spins or revolves around the earth, it will start on the upper bottom and it will go up and down.
Charles Darwin, famous for his theory of evolution, often touted as the father of evolution. Darwin published his book, The Origin of Species, in the year 1589. Here, he presented evidence on how species evolved over time and presented traits and adaptation that differentiate such species. His observational skills as a scientist were extraordinary, and this moved beyond the realms of plants and animals and into the realm of humans. The book Descent of Man, written by Darwin himself, was so impressive yet also very controversial. There he introduced the idea of all organic life, including human beings, being under the realm of evolutionary thinking. One of his most popular theories, other than the theory of evolution, is his idea of natural selection, wherein the species that is able to adapt to the changes in environment.
Good day, Miss. I am Jefferson Arenas from AMT Second Year Alpha, and today I'm going to discuss all about the development of science. The history of science covers the development of science from ancient times to the present. It encompasses all three major branches of science: the natural, social, and formal science. So these three is the key components of the development of science. Formal sciences is a study of formal systems such as those under the branches of logic and mathematics, which use a priori as opposed to empirical methodology. Natural sciences is the study of natural phenomena, including cosmological, geological, physical, chemical, and biological factors of the universe. Natural science can be divided into two main branches: the physical science and life science, or biology. And the social sciences is the study of human behavior in its social and cultural aspects. And to further explain the natural science is one of the branches of science concerned with the description, understanding, and prediction of natural phenomena based on empirical evidence from observation and experimentation. Mechanisms such as peer review and repeatability of findings are used to try to ensure the validity of scientific advances. Natural science can be divided into two main branches: the life science and physical science. Life science is the alternatively known as biology and physical science, and it is subdivided into branches: the physics, chemistry, earth science, and astronomy. These branches of natural science may be further divided into more specialized branches, also known as fields. On the other hand, the social science is the branch of science devoted to the study of societies and the relationships among individuals within those societies. The term was formerly used to refer to the field of sociology, the original science of society, established in the 19th century in addition to sociology. It now encompasses a wide array of academic disciplines, including anthropology, archaeology, linguistics, political science, history, human geography, economics, management science, and psychology. And lastly, the formal science. Formal science is a branch of science studying formal language disciplines concerned with formal systems such as logic, mathematics, statistics, theoretical computer science, artificial intelligence, information theory, game theory, system theory, decision theory, and theoretical linguistics. Whereas the natural sciences and social sciences seek to characterize physical systems and social systems, respectively. Using empirical methods, the formal sciences are language tools concerned with characterizing abstract structures described by symbolic systems. So the branches of formal science include computer science, mathematics, statistics, informal science, and system science. So this is all my part. The development of science is continued to report by my partner, Justice Flores. Justice.
The earliest roots of science can be traced back to roughly 3000 to 1200 BCE or before Common Era in ancient Egypt or Mesopotamia. Their contributions to mathematics, astronomy, and medicine influenced and impacted classical Greek natural philosophy, which sought to provide formal explanations for phenomena in the physical world based on the natural causes. Following the fall of the Western Roman Empire, understanding of Greek worldviews decreased in Latin-speaking Western Europe during the early Middle Ages. Ranges from 400 to 1000 CE or Common Era, but flourished in the Greek-speaking Eastern Roman or Byzantine Empire. During the Islamic Golden Age, the Hellenistic worldview was preserved and incorporated into the Arabic-speaking Muslim world thanks to translation of Greek texts. Between the 10th and the 13th centuries, the recovery of absorption of Greek works and Islamic inquiry into Western Europe revitalized the study of natural philosophy in the West. New ideas and discoveries broke from prior Greek conceptions and traditions during the scientific revolution in 16th to 17th century Europe, transforming natural philosophy. The new science that evolved had a more mechanical worldview, was more mathematically integrated, and was more dependable and open because its knowledge is based on a freshly defined scientific method. In the centuries that followed, there were further revolutions. For example, the 18th century chemical revolution provided new quantitative methods and measurements to chemistry. New viewpoints on energy conservation, the age of the earth, then evolution emerged in the 19th century. New discoveries in genetics and physics in the 20th century laid the groundwork for new subdisciplines like molecular biology and particle physics. Furthermore, the period of big science was ushered in the industrial and military concerns, as well as increasing complexity of new scientific undertakings, particularly following World War II. That would be all. Thank you.